Hello my dear students, this is Sanjay sir from Mathswell YouTube channel. Today we are going to solve few more examples from the applications of trigonometry. So in the last few videos we have seen the examples on the same with the help of angle of elevations. So now we are going to solve the example on how to solve the height and distances if the the angle of depression is given, right? So let's see a few example on the same. Let's see the first example here given. So the question given is, from the top of a 7-meter high building, the angle of elevation of the top of the cable tower is 60 degree and the angle of depression of its foot is 45 degree, and the question is to find or to determine the height of the tower. So just try to understand the situation given in the example and then try to solve it. Okay, so let's see how it can be solved. Students. So let's try to draw the diagram, what is given and what we need to find. From the top of 7-meter high building, so just try to draw a 7-meter high building. So building, whenever the building is there, we need to draw it a perpendicular line like this. Should be drawn with the help of scale, a straight line perpendicular, right, like this, right? So here you are given a tower, 7-meter high building. The angle of elevation to the top of the cable tower is 60 degree and the angle of depression of its foot is 45 degree. Okay, this is a 7-meter high building. Let it be, I will just draw the smaller one like this, because we need to draw the angle of elevation as well as the angle of depression. So let it be the 7-meter high building, let it be AB. AB is the building, right? So the angle of elevation of the top of the cable tower is 60 degree, right? So here you are given the angle of elevation of the top of the tower. So here from this we have the angle of elevation like this, right? And the eye level or the horizontal line will be like this. So angle of elevation we are having from this top of the building is 60 degree, it is given, right? So we can draw the tower here like this. This is a tower, right? And the angle of depression of its foot is 45 degrees. So this is a tower here, a cable tower. So angle of elevation from the same, that is the top of the building, with the angle of depression of its foot. So foot of the tower is here, so the angle of depression of the same, this foot of the tower from this top of the building is given as 45 degree. So here it is given 45 degree. Okay, so this is the distance of the bottom of this building with the bottom of the tower. Let PQ be the tower. Okay, PQ is the tower here, the cable tower, right? So what is the question here? Determine the height of the tower, means we need to find the height PQ. So student, as we have discussed in the previous video, that the angle, the horizontal line of the angle of elevation or the angle of depression is always parallel to the ground level. Means here I can say if it is a point C, suppose C is the point, then we can say that this AC is parallel to BQ, right? AC is parallel to BQ, that is considered here, right? So since this one is a parallel to this, and if you consider AQ as a transversal, so can I say the angle Q, that is angle AQB, is equal to 45 degree, which is equal to the same Yes, we can say it is same here, right? So here I can say this is equal to 45 degree and this will be C. So student, so we are discussing about the angle of depression. Here we have at the point A, which will be same as the angle AQB, as AC and BQ will be parallel to each other, and if we consider AQ as a transversal, then the alternate angle we will have, they are always equal. So as this angle is 45 degree, angle CAQ is 45 degrees, so the angle will be AQB. So I can write the angle AQB is equal to 45 degree, right? So here we are having a right angle triangle. Here the triangle ABQ is a right angle triangle, right? Also the angle ACP is also a right angle triangle. So now to find the height of the tower PQ, what we need to do? So can I say AB and BQ, if we see the quadrilateral ABQC, can we say this quadrilateral is a rectangle? Yes, we can say rectangle, because one of this angle of this quadrilateral is 90 degree. So obviously this will also become 90 degree. So we can say opposite sides are parallel and one of the angle of this quadrilateral is 90 degree, then obviously we can say it is a rectangle, so that we can say their opposite sides are equal. So obviously we can say the length CQ will also equal to 7 meters, same as this. So now this one is a 7 meter. So can you find BQ first? So here we are going to find, we need to find PC only. Once we get PC, we can find PQ by just adding that PC with QC will give us the height of the tower. So that is the steps we need to follow here. So first we will find the BQ in the triangle ABQ. So before solving this example, we just note the things what we have considered here. So what is AB? AB is the height of the building, right? AB height of the building, from the top of which we have the angle of elevation with the top of the tower, right? So here it is given as 7 meters, so I can write the same is equal to QC. QC and AB both are equal. Also you are given, we can consider PQ as the height of the tower. It is a cable tower, we can say. This given cable tower, its height is PQ, that we need to find, which is equal to, we can say it is PC plus QC. So QC is known, that we have seen, that we have written there. So it will be PC plus 7 will give us whatever PC we obtain. If we add 7 meter to it, will give us the PQ, that is the height of the cable tower, right? So now what we need to find, that we need to find the PC here. So to find PC, the remaining part of this tower cable tower, we need to find the part PC of that cable tower, right? So first we consider the triangle ABC. Also we can note that since AC is parallel to BQ, since the ground level and the eye level, they are always parallel to each other, so AC and BQ, not BC, AC and BQ are parallel to each other, so the angle CBQ, they are equal to angle AQB. CAQ, not BQ. CAQ is same as the angle AQB. They are the alternate angles. If you consider AC parallel to BQ and AQ is a transversal, so with the help of this transversal we will have a pair of equal alternate angles, right? So these two are equal, so both are equal to 45 degree here. Both are equal to 45 degree, that is given. So now first we consider the triangle. Consider a triangle ABQ. a right angle triangle ABQ, in which we have angle 45 degree is known, opposite side is known, we need to find the adjacent side. So the ratio in terms of opposite side and adjacent side, it is a tan theta. So I use the definition of tan theta here. Tan theta is opposite by adjacent, opposite side is AB here, adjacent is BQ. How much is theta we know here? Theta given is 45. So tan 45 degree equal to AB by BQ, where AB is 7, BQ we need to find. How much is tan 45? Which is equal to 1. So it is 7 upon BQ. So which gives us BQ equal to, so taken cross multiplication, BQ into 1 is BQ equal to 7 meters. So we got BQ equal to 7 meter. Since BQ is 7 here, this AC will also become 7 meter, right? So we can write here, since from this we can have, we follow this step, after that we come to this one, right? Okay, so now let's continue this one. So here we have, in a quadrilateral is BQC. BQ is the same as AC. Both are equal to 7 meter again. So we can say that ABQC is nothing but a square. So all sides are 7 meters here. This will be AC is equal to 7 meters. So now we consider the next triangle, triangle ACP. In triangle ACP, again it is a right angle triangle. C is the right angle here. So here we know the adjacent side AC of the angle 60 degree, and we need to find PC here, the remaining part of the tower. So base CQ is known, QC is known, we need to find PC. One part is known, one part we need to find. So in triangle ACP we have, again opposite and adjacent side we need to use here. So again we need to use tan theta only. So tan theta is opposite side by adjacent side, opposite side is PC, adjacent side is AC, right? So how much is theta? Theta is 60 degrees, so it is tan 60 degree equal to PC we need to find in the AC is equal to 7. How much is tan 60? Tan 60 is root 3. So root 3 equal to PC by 7, or we can say PC equal to 7 root 3 meters, right? So once we have PC, we can find the height of the tower. So height of the tower, that is cable tower, is equal to, what it will be? It will be PQ, which is equal to PC plus QC. We got PC as 7 root 3 meters, QC we got is 7, so we can say it is 7 times 1 plus root 3 meters. So that is the required height of the cable tower. So in this way, student, we can find the height of the tower using simple definitions of trigonometric functions. Isn't it easy? Yes, it's very easy. So just you need to practice such example and try to understand the situation given in the example and try to apply the trigonometric ratio there. Okay, so with this, let's move ahead with one more example of this type on the angle of depression. Let's see this next example. Now the question is, as observed from the top of a 75-meter lighthouse, high lighthouse, from the sea level, the angles of depression of two ships are given as 30 and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So let's try to draw the diagram with the help of given in the example. Okay, so let's have a lighthouse in the sea. Okay, let it be, this will be a sea, a lighthouse here in the sea. Its height is 75 meter. So there are two ships in the sea. they are just one behind the other. Let these are the two ships, okay, at the sea level. So this is the sea level here. Let AB is the height of the lighthouse, and C and D are the two ships in the sea. So the distance or the angles of depression are given from this top of the lighthouse. So they are, so to find the angle of depression we must know the eye level. So angle of depressions are given as 30 degree and 45 degree. So this is a 30 degree angle and this will be 45 degree angle, right? So again we can use that parallel lines and the transversal. If we consider this, suppose A, B, C, D. See, AE is the eye level, so we can say AE is parallel to this BD. So, and if we consider AD as a transversal, so the angle EAD will be equal to ADB. So this will also become 30 degree, right? Same as this angle 30 degree. Similarly, we can consider the angle of depression EAC. So again considering AE and BD as the two parallel lines and AC is a transversal, so then we can say this angle will be same as the angle EAC, which is equal to 45 degree, right students? So here we are having two right angle triangles. One is the triangle ABC, another one is the triangle ABD. Both are the right angle at the point B. So now with the help of this, the question is to find the distance between the two ships. Let the distance between two ships C and D be x. So if we are able to find the distance BD and the distance BC and BD, so if we are able to find it, so difference of them will give us x, that is CD. Okay, so let's find BC first with the help of the triangle ABC. So first note the notations here. Let AB is a height of the lighthouse, in the sea. Okay, let it be, it is given as 75 meter. Write it first. After that you are given the angles of depression. We can say CD. CD is the difference, required difference, or the distance, we can say the distance between two ships A and B, sorry, not A and B, they are C and D. The C and D are the two ships, so distance between them is equal to CD. Okay, so let it be equal to x, let the CD be x meters, so that we need to find here. So now using these angles of depression and the angles we are having the alternate angles, using that alternate angles we can say, so from figure we can say, we can note all these things. So here AE is parallel to BD, so we can say that angle EAD, first we can take AD as a transversal. So with AD as a transversal, we can say that the angle EAD is equal to angle ADB, right? And both are equal to 30 degree. Okay, also from the same AE parallel to BD, if AC is a transversal, when AC is a transversal, we have a pair of alternate angle EAC is equal to angle ACB, the alternate angles whose measure will be equal to 45 degree. So with the help of this we can use this right angle triangle. So we consider the triangle first, triangle ABC. Okay, triangle ABC. In triangle ABC we are given the opposite side of angle 45 degree, we need to find the adjacent side. So obviously we use the tan theta. So tan theta equal to opposite side is AB, adjacent side is BC. Tan theta is 45 here, tan 45 is equal to AB is 75 and BC is we need to find. So since tan 45 is 1, it is 75 by BC, or we can say BC is equal to 75 meters. Okay, we got BC now. So after that we consider the triangle ABD now. In triangle ABD, what we have? We can say that again we use the tan theta only. We have tan theta equal to opposite side is AB, adjacent side of the angle 30 is BD. So it is tan of 30 degree is equal to AB is again same 75 and your BD will be equal to. So what is the BD? BD will be equal to BC plus CD. So it is, we can say here we can write BD is equal to BC plus CD. BC we got as 75 and CD we denote it as X. So we can write here instead of BD I can write it as 75 plus X. And how much is tan 30? Tan 30 is 1 by root 3, right? Is equal to 75 upon 75 plus X. So what this gives us? It gives us, by taking cross multiplication, 75 plus X is equal to 75 root 3. So it gives us the value of X from this. X is equal to 75 root 3 minus 75. So taken 75 common from this, it will be root 3 minus 1 is the X. And what is that X? S takes nothing but the distance between the two ships. Hence we can write distance between two ships is equal to 75 times root 3 minus 1 meters, right? So that is our required answer. So student, hope everyone understood this example, right? So just practice this example, students. It's a very one of the not we can say easy, but it can be understandable, right? So you can practice such type of example so that you can try more examples from this, right? So with this note, going to end this today's video. So see you in the next video with the more interesting topic from your syllabus. Thank you.